Okay, today we're going to be learning a little bit about the difference between series and parallel circuits. You don't need to write this down, but generally the way you know it's a series circuit is that the current has to travel through each resistor. So there's basically one path and all the current's going to go the same way. But in a parallel circuit, the current has options. So it's going to split up and there's different ways that the current could actually go. So here's some examples where we're just going to decide, is it series or is it parallel? In this case, because all the current has to go through both of those, this would be a series circuit. In this case, because when the current comes out of the battery, it can choose to either go this way or it can choose to go this way. It cannot do both of those. It can't backtrack and kind of go snake around and go like that. It can't go backwards through the circuit. So this would be parallel because there's two options for the circuit. Take a moment and think about it, but when the current comes out of the battery, it has to go this way, has to go this way, has to go this way. There is only one path, so that is a series circuit. Okay. In this case, once again, even though it kind of looks like parallel lines, if you trace the circuit, there is only one way for the current to go through, so that would be series as well. In this case, you can see when the current gets here, this is called a junction because it either goes this way or this way. It cannot do both, so this is a parallel circuit. This one also is parallel. The current can either go the left loop or the right loop. It cannot snake around because that would require some amount of backtracking, and it has to go from one side of the battery to the other. So this is parallel. There's one loop on the right and one loop on the left. Okay, this one we're going to hold off on for just a quick second, and I want to explain what this is. In this case, it may look like a parallel connection, but you may have heard the phrase that current takes the path of least resistance. Well, in this case, when the current gets here, it has a choice. It can either go through a wire, which has basically no resistance, or it can go through this really difficult path, which includes a resistor. Well, essentially all of the current is going to choose this path because it's significantly easier. It's kind of like, you deciding to take an elevator up the Sears Tower instead of walking on the stairs, right? Everybody's going this way. So since all of the current is going in this direction, this has no current going through it at all, and this is what's actually called a short circuit. This means that all of the current is going from one side of the battery straight back to the other side without going through any resistors. And this is really, really dangerous because low resistance leads to a very high current. And that is what actually can cause fires in your home. And this is why we have circuit breakers in our home to prevent this from happening. If a wire should, if the insulation should get bare on it and it cross with something and cause this to occur, that's why your circuit breaker is there, so it can shut that down in the event that you have this situation of a short circuit. Because again, this is absolutely a fire hazard. Okay, so there's two rules. If you just want to jot these at the top of the series side of your series parallel chart that you received today, they're very short, but there's basically two rules that tell us how circuits work. The first is called Kirchhoff's junction rule, and it's honestly kind of common sense. It says the current that goes into a junction has to equal the current that comes out, because you can't lose any of the electrons. So the electrons coming in have to come back out the other side. So if I have current going in like this, and there's a junction and it splits, let's say there were 10 amps coming in. Well, if 7 amps decide to go this way, then that means there must be 3 amps going that way. So that's what I mean by the current in equals the current out. Right? You couldn't have 10 in and then 7 and 2 or something like that. All of the electrons have to be accounted for. Right? The next rule is called the loop rule, and it says that the potential difference of the battery is equal to the sum of the potential difference of each resistor in a loop. So I'll give you a quick example. Again, if you just want to write this somewhere on your paper, it could be down at the bottom. It doesn't really matter where it is or your own separate paper. But if we have a battery here And I'm going to draw a parallel circuit. Here I'm talking about the potential difference. I'm not talking about the current, so I'm talking about delta V. Let's imagine that this is a 12-volt battery. Well, I'm going to identify a loop. The current could go this way. That would be a loop. And since there's only one resistor in that loop, its potential difference actually has to match the battery. So this would be 12 volts. Now, if the current went the other way, it would have to travel through two resistors. So these two resistors together must have a potential difference equal to the 12 volts. So for instance, if this one had a potential difference of 7 volts, this would have to be 5 volts because the two together has to add up to the battery because they're the only two in the circuit. So basically using these rules, we can summarize what's going on with both series and parallel circuits. Okay, so let's go ahead and look at series circuits first. The definition of a series circuit is it is a circuit with a single path. So there's only one way for the little electrons to move. And the diagram for this is going to look like this. I'm putting 3 resistors in my circuit for no particular reason, but you can see all of the current has to go through the first, has to go through the second, has to go through the third. So when I think about what's the same in each resistor, it's important to know this fact. This is quite important. Well, again, because there's only one path for the current to go through, the current that goes into this one has to come out, and then it has to go into this one, and then it comes back out, and it has to go through this one, and then it goes through the battery. So all of those resistors, regardless of how big or small the resistance is, all of them have to have the same amount of current. So that means we can summarize our current by saying if this is resistor 1, and this is resistor 2, and this is resistor 3, the current in each one of those has to be the same. So the current going through resistor 1 equals the current in resistor 2 equals the current in resistor 3, and so on. So all of them have the same amount of current. Now, for potential difference, this comes from the loop rule. If I think about the potential difference, and you don't need to add this into your picture, but let's imagine that this was 20 volts over here. Well, as I go around, the potential difference of all 3 of these together has to add up to the 20. So let me kind of explain why. Remember what potential difference is. If you remember that little penguin toy I showed you, it's the electrons being lifted up, not literally, but we'll use that analogy. So the electrons are being lifted up to a height of 20, let's say. Okay, that's what the 20 volts means. That's how much it's been lifted up. Well, by the time you get through the circuit, you've got to be back to where you started. So this first resistor, maybe it takes me down 5 volts. So maybe its potential is 5. Well, then I go down the next resistor. Well, the next resistor has to have a potential difference. Maybe it takes me down 10 volts. Well, I've got to get down the rest of the way, so the last one has to be, well, it would be 5 volts again. So that way, the total of the battery is equal to the total of the 3 resistors. So if I add the potentials together, I get the potential of the battery. So the rule, and again, this is only for series that this works, that the potential difference of the battery is equal to the potential difference of the first resistor plus the potential difference of the second plus the potential difference of the third, and so on. Okay. Great. The next thing we need to know is how do you find equivalent resistance? And what equivalent resistance means is that we're trying to say, okay, instead of the battery having these 3 resistors attached, what could I replace these 3 resistors with? And again, don't write that on your paper, but in order for the battery to experience the same amount of resistance. So basically, from the battery's point of view, what could we replace all of these resistors with so that the resistance of the circuit is still the same, but it's only 1 resistor instead of 3? And you actually figured this out in the activity from last week, or you should have, that for series, it's as simple as it could possibly be. The equivalent resistance is just equal to the sum of the individual resistances. So if one is 2 ohms and 5 ohms and 10 ohms, it would be 2 plus 5 is 7, plus 10 is 17 ohms of resistance overall. Okay, so here are the steps, and we're not going to use this too much this week, but you'll see us using this next week, or not next week, but in the coming days. So step 1 is going to be to find the equivalent resistance. So every time we have a circuit, the first thing we're going to do is we're going to find the equivalent resistance. And then the next thing we're always going to do is we're always going to find the current in the battery. And the way we find the current in the battery is we use Ohm's law, and Ohm's law is delta V equals IR. But specifically, anytime we're talking about the battery, so this would be the delta V of the battery, 10 volts, 9 volts, whatever it is, and I want to know the current in the battery, the R that I use is always the equivalent resistance, because from the battery's point of view, that's how much overall resistance there is in the circuit. So I would simply divide that, and that would give me the value of the current in the battery. And then you continue from there. So, and we'll explain later exactly how you continue that, but those are always going to be your first 2 steps. Right, now, some advantages and disadvantages for series. One, it could be both an advantage or a disadvantage. If you think about Christmas lights, if you ever have a string of lights where when one goes out, they all go out, that is a series connection. So if one goes out, they all go out. And now with Christmas lights, that's not really great. I remember when I was a kid, our lights were in series, and I would be the one stuck trying to find the one that wasn't working to get them all working again. Most now are not done in series, so that if one goes out, it doesn't affect the whole thing. But if you think about in your home, there is one place where we want this to occur. We use this to our advantage in the circuit breaker. The circuit breaker is in series. Each little flip of that circuit breaker is in series with a different portion of your home. So that way, if the current gets too high in that portion in your home, it shuts that whole section down. It can't bypass it, it just shuts it down and stops the current from flowing completely so that you don't have the risk of a fire. So that is definitely, there are times when we absolutely want, when one goes out, the whole thing shuts down. Okay, that's the end of our quick lesson on series. We'll go ahead and continue with the next video, learning very quickly about parallel circuits.